see the slides clearly? Could somebody just give me a nod and I'll just continue? Great. Thanks. Well, my name's Mark Rounsevell. I'm from the Karlsruhe Institute of Technology, as just mentioned. I'm also at the University of Edinburgh in the UK. And I'm going to be talking about, with a focus in Europe, although there are lots of messages that are really relevant here at the global scale. We need to look at reforestation issues globally, as I'll introduce to you in a moment. And I think actually my talk is going to be a nice follow-on from to increase the area of forest is to enhance the land carbon sink as part of climate change mitigation strategies. And this is just some data taken from a publication that you'll see here, which looked at, if you try to achieve the Bonn challenge target, 350 million hectares of new trees planted globally, then depending on the type of ecosystem restoration that you're engaged in, you get very different quantities of carbon. So that pretty much just reinforces what Susan was just saying. But actually what I'm particularly interested in, and what I'm going to be talking about more here, is actually the area questions themselves. And the question we have to ask ourselves is, okay, if we think that the Bonn Challenge is a good idea from climate change mitigation purposes, from forest ecosystem restoration purposes, then where does this quantity of land, the 350 million hectares, come from? Yeah, and just to put that into context, the area of the European Union, 27 member states, is 420 million hectares, right? So you're nearly talking about an area of land about the size, almost the size of the European Union. So that's a significant amount of land. So let's just have some reflection on where we can find that land in order to encourage reforestation. And it ultimately comes back to being a fundamental question of the competition for land. So land is pretty much a finite resource. There's only so much of it. There's a lot of competition for that land across multiple sectors, the food and fiber production, obviously reforestation, energy production in terms of biomass, but also finding space for solar panels and wind turbines, but also for nature conservation across a wide range of different biomes and living space for people. So there's massive competition for this finite resource. And we know that there's a big policy initiatives going on at the moment as well. So again, within the European Union, the EU biodiversity strategy has a target of planting 3 billion trees by 2030. It sounds like an enormous quantity of trees, and I'll come back to that number a little bit later on. So where will the land come from for these types of targets? The EU biodiversity plan, the Bonn Challenge, etc., that importantly avoid something which is really critical in this debate, which is the displacement effect of reforestation, or otherwise termed indirect land use change. And this is some interesting data I've picked up here from Our World in Data. And what this shows, each point is an individual country. The y-axis shows the annual change in domestic forest area, so domestic reforestation in each of those countries. And it's been plotted against the deforestation that's embedded in the imports of goods to those individual countries. And the imports are primarily, in this case, for food production. And you can see there is quite a strong relationship here. So what we're seeing is as countries are increasing their domestic reforestation, they're actually responsible for deforestation in other parts of the world. So that's a no-win game. You're reforesting one place and deforesting another place. So we really need to avoid that. And unfortunately, there's often very little recognition of this as being a major problem. The embedded deforestation in European food imports, for example. We've had a massive increase in imports of oilseeds, particularly soybeans, for example, but also increase in goods used for bioenergy production. A lot of those imports are used to produce meat and milk, which are then exported as well. And since about the 1990s, the imports of food into the European Union have more or less doubled. So this is a critical factor. And this is a calculation we did and published recently, looking at the reforestation area in the EU from 1990 to 2014. It's around about 12.6 million hectares. And again, to put that in context, that's about half the area of the United Kingdom. So a fairly significant amount of reforestation in Europe over that period of time. But actually, we also calculated the embedded deforestation in those food imports to the European Union over that time, which was 11.3 million hectares. So you can see from this, they're almost exactly matching, which pretty much reflects the graphic that I showed you previously. So this is a critical factor. So we still need to find ways in which we can find new land, which is not simply displacing the problem to other parts of the world when we're looking for land for reforestation. So how can we do that? This is the big question. Okay. It may seem strange to you that I'm going to start talking about agriculture in a workshop that's all about forests, but it's absolutely critical that we reflect on the contribution of the food system to this debate. So food production accounts for around about 38% of the global land surface. So it's an enormous land consumer. And we know that actually if we can act on both the supply side of the food system, but also the demand side for food, then that could be critical in freeing up land for planting of trees. So demand side changes include things like dietary changes, a shift towards plant-based diets away from livestock products, reducing waste and losses in the food system, even reduce the amount of livestock products we feed to pets, which is not insignificant. We did a study on that a couple of years ago. But also we need to look at the supply side changes in terms of disruptive technologies in the food system, things like indoor farming and CRISPR gene editing technologies, et cetera, et cetera. And what I'm going to ask here, and just give you some examples in a moment, is this fundamental question: is society capable of significant demand side changes that actually could free up land for reforestation? Or are we potentially faced with what everyone wants to avoid, the sort of technological solutions of perhaps decoupling food production from the land? So a technological solution to the supply side of food. So let's look at some of the potential for this. This is a study we did, again, looking at the European Union, when we're trying to look at this interplay between the potential for reforestation in Europe and its interplay with the food system. So what you can see here on this graphic, it's slightly complex, but I'll just take you through it quickly. Here you've got forest area, and currently we're around about 138 million hectares in Europe. That's the baseline condition here. And along the bottom axis here, we have calorific intake of food by people. This is the European average, and this is the global average down here. And what each of these points represent is a model run of an integrated assessment model for Europe, where we've explored changing different parameters in the model. So here we've looked at increasing yields. This is a percentage change, so up to 75% increases in yields. If you can get more food production out of an area of land, you need less land, more land for trees. Alternatively, if we look at dietary shifts, we're looking at things like no change in diets. If we have beef substitution, beef's a very land demanding product, or just simply reducing meat. So these are different combinations and a no meat scenario as well. And what we see horizontally here are different targets. So I put on here the bond challenge target. So this is like the European land area proportional take of the total bond challenge. And also some other targets here from an article by Detlef van Vuren, which we're looking at targets for reforestation for climate change mitigation. So that's what we're trying to achieve. That's the target. And what we can see for these different model runs is it's really tough to do it. If you want no change in your dietary situation, you've got to actually reduce your calorific input before you can start meeting these targets. That's the sort of red points down here. And it's helped if you have massive increases in yield improvements as well. And most of the model runs that are actually achieving these targets are in this sort of turquoisey, greeny, bluey colors, which are actually all of the very strongly reduced meat consumption, including no meat scenarios. So really these are fundamental societal issues around dietary changes, about changes in calorific input that would be necessary. So transformation within the European food system, which would be necessary to meet some of these reforestation targets. That's quite critical. Is it doable? It doesn't look too likely when you look at those graphics, but we could sort of reframe this in a different way. And apologies for the people from the US in the audience. But in this particular example, we were doing a contrast of two different dietary situations, just to see how significant diet is in freeing up land. What we've got here is what we call the half index, human appropriation of land for food. And this simply represents a percentage of planet Earth. So currently, as I mentioned, agricultural food production is around about 38%. That's the dotted line here, you see. And that breaks down in this bar into about 2/3 of pasture area to about 1/3 of cropland area. Some of this cropland, of course, also being used for livestock production. And what we got here, these bars show what would happen if the whole world ate the diet of a typical person from the US. in terms of the quantity of consumption, the number of calories, but also the profile, the types of goods that are produced. So the US, quite high calorific consumption, quite high beef consumption. And if you combine those together, you would actually require 98% of planet Earth to supply the global population with an average US diet. Clearly not going to happen. The contrast we had here is to look at an Indian diet, lower in calorific intake, very, very strong for cultural reasons, less consumption of meat, particularly beef, culturally not relevant, not allowed. And what you see is that the values down here for that combined quantity and quality, it's less than 20%. It's around about 17% of the surface of the Earth. So we're basically halved the area of land needed to feed the global population if everyone ate that type of diet. And you could think of this in reforestation terms, this big gap here between where we are today and where we could be under this particular stylized scenario is a massive area of land that could be used for reforestation. So really important. Okay, the problem is, of course, that's the half index calculated for all of the countries of the world. So we're not picking on the US. US is actually not the worst in terms of land area consumed. That I won't go into the details. But what we see is, countries like the US, that's the top figure here. Actually, the half index is reducing through time as people are shifting towards more plant-based diets. The same sort of trend in the UK as well, which is that green curve. But also what we see is other countries of the world. This is the blue one here is Brazil. The pink curve here is China, large population countries which are now shifting towards the consumption of more meat. So actually what we're observing is that the gains we're getting in one place are really being offset by losses in another country. So it doesn't seem that society is really shifting towards being able to do something about this. Okay, so let's just try and be a little bit more positive about this situation. I realize you can't read all the details on this table, but don't worry about it. I'm just going to take you through some of the main points. This was a study we did looking at transformation in the food system, the global food system, through marginal gains, is what we termed. And we looked at a wide range of indicators that look at production efficiency, reducing losses and waste in the food system, and shifting diets, and explored substitution for different products here, as well as move towards plant-based diets, a whole range of different reducing losses from along the value chains, and improvements in the supply side in terms of production efficiency. And in each case, we just looked at 1 or 2%, so marginal differences in changes in a lot of these things. And collectively, it added up to this conclusion. A set of marginal food system changes could collectively reduce the agricultural land required globally for food production by 21%, 21% of that 38% of area. So that's a massive amount of land. And again, that's the sort of potential that we really need to be exploring in terms of the potential for reforestation. I just want to have a quick nod, though, to another issue, because as I mentioned earlier, we know there's a lot of competition for land. And one of the big issues that's been raised at the moment, and governments seem to be very keen on in terms of a climate change mitigation strategy based on land, is the large-scale use of bioenergy. And this really is just not a good idea. The problem is, and this is again a study we looked, it's more like a sensitivity analysis, looking at, again in Europe, if you increase the area of bioenergy cropland in Europe, how does that affect other land uses? If you actually prevent further food imports, i.e. you're preventing that indirect land use of change effect, the only place that bioenergy can go is into forests. So you get deforestation, a completely perverse outcome. Alternatively, if you allow increases in food imports, you just get that forest area decline in other parts of the world. So it's exactly the same effect. It's just changing the location. And if you start looking at that in terms of net carbon benefits, actually, these are negative trends here. I won't go into the details of how we do these calculations. There's no time for that. But actually, large-scale bioenergy has negative carbon benefits. It's a completely stupid idea, frankly. And it competes for land. Why aren't we planting trees? And a lot of these bioenergy assessments don't look at the counterfactual of, rather than using land for bioenergy, why don't we use that land for reforestation and store carbon in those ways? So there's some critical issues there. My final slide before I just wrap up is actually just to look a little bit on the supply side. And this is a bit more, it's a little bit wacky and a bit of science fiction perhaps, but I have a colleague who's been working on issues around what are termed disruptive technologies in the food system, including, for example, the potential for vertical farming. So if you look at traditional systems, this is the area of wheat production across the world. It's one layer, there's this planet Earth. you've got diurnal cycles, you get one harvest a year. If you could scale that up, and you don't have to believe these figures entirely, but if you can increase the number of harvests, if you're using renewable energy from solar to have pretty much sort of day-round growing, and you can stack layers of production, however those might be, if you add all that up, you can compress the global area in this particular scenario. The global area wheat production could be compressed into an area the size of Belgium. So massive land savings, and think what you could do with all that land in terms of tree planting. So if we can start moving towards decoupling food production from the land, that means significantly more land available for reforestation. Okay, I think there's lots of discussions right now. Last slide, just to wrap up. So reforestation has to face the critical challenge of the competition for land. If we don't crack that, then we can sort of forget about using reforestation for ecosystem restoration purposes and also as a land-based mitigation perspective. And to do that, we need to act in multiple ways on both the supply and demand side of food production. Food production is critical here because we have to feed a growing population, but we need that agricultural land to be freed up to allow space for reforestation. We have to be really careful about avoiding indirect effects and not kidding ourselves that we've got this fantastic reforestation program going on in our country X, but actually it's causing deforestation elsewhere. Bioenergy really at large scales is not helpful at all. We really need to be getting away from that as a climate change mitigation strategy. And I'm asking this question, can society really do some of the major changes required in dietary changes, in reducing food waste that's needed to save land in order to increase reforestation? And maybe we'll need to start thinking about fairly drastic technological solutions based on decoupling food production using disruptive technologies within the food system in order to find that space for reforestation. So thank you very much for your attention. That's all I have to say. Questions come later, I gather.
Thank you very much, Mark. So we now have Chris Woodall from the Department of Agriculture, Forest Service, Forest Inventory and Analysis Program from the US. Chris, we can see you. So.
Oh, you can see me? Okay, great. Let me share my presentation here. Just let me know when it comes up.
Yeah, that's up. We can see you in the presentation.
All right, great. Thank you. And thanks, well, to the organizers for inviting me to this opportunity, and especially to the co-presenters, Susan and Mark. Really great ideas, comments. I know we're running behind on time a little bit here, so I'll try to incorporate a number of thoughts. So I've worked for the Forest Inventory and Analysis Program of the U.S. Forest Service for over 20 years on many topics, stand dynamics, carbon, etc. One opportunity with the pandemic, COVID, is that the USDA is doing kind of an experiment on me and giving me the opportunity to serve in Washington virtually as a scientist. They usually don't have scientists serve on the staff there, so I serve as an interface between USDA, Forest Service scientists, and policymakers on a number of issues. Of course, AR, afforestation, reforestation is one of them. So quickly, the outline, I'll talk about policy directions in the U.S., recent ones, our resource situation. So this is going to be U.S. focused talk on AR, definitely, but talking about quantitative results and how that kind of links to some of the prior talks which you just heard from. So with the new administration, President Biden coming in and a new Congress, there's been a real push in the United States toward what we're calling climate smart forestry practices. Afforestation and reforestation is one of those practices in a toolbox of numerous ones. You're seeing this kind of policy push come out in numerous fora, such as United Nations INDC from the US, where we're talking about here in 2021, supporting the scaling of climate smart practices, including reforestation. Our own Department of Agriculture sending out orders to start to prepare our organization to track the benefits of such practices. I'm the lead coordinating author of our revisions to greenhouse gas guidelines, which will be coming out later this year, as far as default AR rates or carbon accumulation, topics that Susan had touched on. The White House here in January announced a task force interagency to really improve our monitoring of greenhouse gases, especially focused on ag and forests. I'm the representative from the Forest Service to that White House working group currently. And then we have here just more recently from the president, the Earth Day announcement of an order to strengthen America's forests. So that's a human emotion. And so when a scientist thinks about strengthening, we got to, what does that mean? How do we turn that into objective and